Okay, this video is the completion of the notes for absolute value equations and inequalities for day 5. It's the back side, and it's for my first period class because we didn't get through all the notes. However, really anybody, if you need some more review, can watch it. So what we said was when we're solving for absolute value, we need to break it up into two equations or inequalities. And when we break it up into two inequalities, the first one we write exactly the same. We just take out the absolute value and we leave everything exactly the same. The second one, we are going to flip the inequality sign and change the sign of what's on the right. So again, this one in green, all I did was take out the the absolute value sign. This one here, I took out the absolute value sign and then I swapped this and I changed the sign of this. So now I have two equations to solve. So I'm going to do plus 9 plus 9. That gives me 4x is less than or equal to 30. Divide by 4, divide by 4. And I get x is less than or equal to, these are both even numbers, I can divide by 2, so I get 15 over 2. On this one, same thing, plus 9 plus 9. I get 4x is greater than or equal to negative 12. Divide by 4, and I get x is greater than or equal to negative 3. When I put these on my number line, the negative, of course, goes on the left. It's smaller than any positive number. I have closed circles because I have that or equal part. This is less than or equal, greater than or equal. And when I look at this one, if I'm less than or equal to this number, I'm going to the left. These numbers are smaller. This one, if I'm greater than or equal to, I'm going to the right. So this actually is an and inequality. It's a sandwich. It's all of these in between. So same thing with the next one. On this one, in class we talked about the fact that I have to get the absolute value by itself before I can take it out of the absolute value sign. So I have this 3. I'm going to divide both sides by 3 because this is saying I am multiplying by 3. So the opposite of multiplying is dividing. So I divide both sides by 3 and I get this. And then once the absolute value is by itself, then I can do this and take it out. So again, the green one, all I did was get rid of the absolute value signs. I left everything the same exact everything. On this one, I flipped the inequality sign. So here I flipped the inequality sign and I changed the sign of the number on the right. So now I'm going to solve. So I have minus 5, minus 5. Negative x is less than 1. And then divide by negative 1. And again, when I divide by negative 1, I am flipping the sign. Okay, on this one, minus 5, minus 5. Negative x is greater than negative 11. And again, whenever I divide or multiply by a negative, I'm going to flip my inequality sign. So I have x is greater than negative 1. X is less than 11. When I draw this number line, of course, the negative number is smaller. It goes on the left. The 11 is bigger. It goes on the right. I have open circles this time because I only have greater than and less than. And greater than means I'm going to the right of this number, and less than 11 means I'm going to the left. So this is also an and inequality. It's sandwiched in between. All right, next example. So this one was already by itself, so I didn't need to do anything before I took it out of the absolute value. So my green one, I took it out of the absolute value and left everything the same. This one, when I took it out, I flipped the sign, the inequality sign, and I changed the sign. So now to solve, I need to get the variable by itself. I'm going to add 2 to both sides. That gives me 20. And then divide by 3, and I can't reduce 20 over 3. This one, same thing. I'm going to add 2 to both sides. That gives me 3x is less than negative 16. Divide by 3, and again, I can't reduce negative 16 over 3. On my number line, my negative number is smaller, so it goes on the left. My positive number is bigger, it goes on the right. I have open circles. And now I'm looking for numbers bigger. Numbers bigger than 20 over 3 are going to be to the right. Numbers smaller than negative 16 over 3 are going to be to the left. This is an OR inequality. It goes out like oars of a boat. Okay, next example. This one again, before we started, we did this in class, we had to get the absolute value by itself. So whenever we're solving equations, we always do the addition subtraction first. So get rid of, I have this 2, but that's multiplied, and I have negative 16. So I need to get rid of this first by adding 16 to both sides, and I can divide both sides by 2. So that gives me this. And now that the absolute value is by itself, I can get rid of those absolute value signs and just rewrite it. That's the green one. And then I rewrite flipping the inequality and switching the sign. Now I have two inequalities to solve. So I have negative 3x is greater than or equal to negative 3. And when I divide by negative 3, I have to flip the inequality. That gives me x is less than or equal to 1. And on this side, same thing, minus 10, minus 10. I get negative 3x is less than or equal to negative 17. Divide by negative 3. Flip my inequality, and I get positive 17/3. So this one, as we're graphing, think about which number is bigger. Is 1 bigger or 17/3? Well, that's just 1. 3 I know goes into 17 at least 5 times, so this number is bigger. So it's going to be on my right, and this number is going to be on my left. And I could put this in my calculator too, just to see exactly what it is, but I know it's going to be 5 something. 5 point something. All right, I have closed circles, right, because I have that or equal to here. So less than 1. Less than 1 means I'm going to the left. Greater than 17/3 means I'm going toward the right. This is an OR inequality. All right, my last two are kind of special cases. If we look at this one, I have an absolute value greater than or equal to a negative number, except that we know absolute values are always going to be positive. So basically this is saying positive number greater than or equal to a negative. Well, positive numbers are always greater than negative numbers, always. Because we always have a positive number is always greater than any negative number and so the answer to this one is just going to be all real numbers. Which means if I graph this one, it's just going to be everything. And then our second special case is this one. Now this one's not ready yet. I have this minus 8, so I need to do plus 8 to get rid of it. I need that absolute value by itself. So this gives me negative 2. Well, on this side, we just said that an absolute value is always bigger than a negative number. Well, this one's now saying I have an absolute value less than a negative number. Well, we can't have a positive number ever be less than a negative number. Positive numbers are always bigger. We just said that. So this one is going to be no solution. And again, that's because absolute value is always positive, and a positive number is always greater. In other words, it's never less than a negative number. So for the two special cases, what you want to look for is once your absolute value is by itself, so up here it's not by itself yet, but once you get the absolute value by itself, you're looking for, is there a negative number on the right? Because if you have an absolute value and a negative number on the right, you're either going to have no solution or all real numbers. So then you need to think it through. Positive number, is that going to be less than a negative number? No, that one is no solution. On this one, positive number greater than a negative number? Yes, always. That's going to be all real numbers.